Hello, good afternoon, everybody, and you're welcome to the concluding part of this series, IP addressing. I'm very sure for those of you that are seeing this, you must have seen the initial part where we discussed so many things, communicating across the network, the importance of the IP address. So, um, in this part, we'll talk about the types of IP address, the classes of IP address, and we'll talk about methods of assigning IP addresses to devices. When I say devices, I'm going to concentrate on your system. But then, if you want to know about other devices, the knowledge of this you can carry it into the system part. It's basically the same. Just find a way of navigating around. All right. Okay. So, uh, thank you. I really want to appreciate everybody that has been following us on YouTube. I've seen so many, um, seen some comments, seen a lot of views. Okay. So, thank you. Let's get into the meat of it. Methods of assigning IP addresses to to hosts. Now, there are so many ways you could assign IP addresses. There's the automatic assigning IP addresses. That's where we have something I've talked about before, the DHCP. That is the Dynamic Host Configuration Protocol. Well, let's say this is my network. I have devices, and I have a particular server that performs the work of DHCP. Right? No, okay. I have a device here. I have host. Now, two ways we could actually, of course, if you have auto, there's manual, right? So I could easily go into each system or and manually assign them IP addresses, like something like this. If you go to your network sharing center, if your network and sharing center, you go into your network and sharing center, and you click change adapter settings. You could easily go into each adapter. Okay, I'm not going to use this Wi-Fi adapter. You could easily go into each adapter and say go to your um, IPv4. Of course, I told you we have IPv6. We're going to cover IPv6 in the CCNA series. So once you go into your IPv6, your IPv4, you could manually go in and type in IP addresses. So I'm just going to generate one now. It's not see if it's going to work. I'm just picking one from the sky right now, and yeah, you can give it a manual IP address, give it a subnet mask, tell it which default gateway to connect to, and manually type in the preferred DNS server. I believe you do know what DNS is. Yeah, if you don't know, see our recording on DNS. We have two parts, part one and part two. Awesome. Okay, so that is manual configuration for configuring IP addresses. Okay, I could do that in my network. Manually configure each system. Yes, sometimes this is not, well, not sometimes this is not entirely efficient, because it gives room for human error. Probably I've given him um, something something dot one, and I want to give this guy dot one also. It's going to cause confusion and connectivity issues, the errors. All right. So yes, you can do it. You can manually, if your network says about 5, 10 clients on the network. Yes, you can manually assign IP address to them to, okay, for you understand. But when this doesn't particularly scale to big networks, when we're talking of 50 systems, and we're talking across geographical locations, when you have a big one and everybody is part of your network, and you're trying to assign, let's say you manage a campus, let's say a school. manually assigning IP address to them is just crazy. It's out of the world. So that's why we have the DHCP, the Dynamic Host Configuration Protocol. I'm going to show you an example of a DHCP. Excuse me. We have many devices that can perform the functions of a DHCP server on your network. You have you could use what we call this. This is a Windows 2012 um, server. I have a Windows 2012 server here configured. You could use that to do DHCP. No, DHCP. Um, we look at okay. I don't have a DHCP server configured yet on this, but I could put a DHCP server here if I want. I could go in here and say DHCP server hardware and say blah 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 yada 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 and put up a DHCP. No, I could do that, but I wouldn't want to go into all that now. Now I could make this into a DHCP server. Did I say Andrew? Oh yeah, don't mind me. I didn't get what I was looking for. But now you get the whole idea. So I could make this guy into a DHCP server, and on my network, when clients come on the network using different processes like remember this when we talked about the app. No, 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 no. Yeah, this. We'll talk about this address resolution protocol. It looks for a DSCP. It goes okay. Before I even go there, the process of DSCP is a different thing entirely. But there is an acronym I use for DSCP, DORA. That is discover, offer, request, and answer, something like that. So now using this, it goes on the network and looks for a DHCP server and gets its those configuration automatically from the DHCP server. But let me show you a classic DHCP server I use on my network presently. I'm quickly going to just log into it. Yes, 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 yes. Oh, great, great. Okay, good. I used to have CyberRoom. I'm not advertising for CyberRoom. No, don't get it wrong. Okay, so in here I've configured DSCP. I've configured DSCP to to assign this IP address out in this range from 170 to 214. All right. So I'll tell it, okay, assign this IP address. Let's start from this end here. Um, Give it a default subnet mask of this. Use this default gateway when you're giving them. So it's every aspect of the DHCP of the IP addressing configuration. In fact, I even put DNS server to to assign to my client in here. You can see where it's assigning DNS server. Even I have options for Win server. Nobody really uses Win servers anymore, but that is that. So you can configure this as an example of a device performing the function of a DHCP server. Um, uh, there are other there are other devices you could use to configure DSCP. So that is that for the auto and automatic assigning of DSCP, that is using automatic assigning of IP addresses using DSCP, and we have the manual configuration. So having said that, I think I can move on to the next in line of my topic. Let's talk about classes of IP addresses. Classes of IP addresses. Um, let me clean this. Let me clean this. So, classes of IP addresses. Classes. We have well, in my terminology, we have classes and we have types. So let's talk about classes. So, classes of IP addresses. Now we have the class A. You know what? Let me type it. Let me type this out. Yes, I quickly type it so that you watch me write all my rubbish. Now these are the classes of IP addresses that we have. We have the class A through class E. So from in the class A IP addresses, any IP addresses that start between that has its fixed octet. Remember I told you IP addresses has 4 octet. A classic example is 192.168.1.1. Another example is 10.68.1.125. Another example is one 175 dot 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 3.120 dot, okay, this looks like 126.26. This is another example. Now mere looking at the first octet, you can tell which class of IP addresses this guy belongs to. So based on this rule here, not rule, based on this classification here, we can see that this particular IP address falls between, yes, in class C. So based on this guy is what, a class C IP address. Why? Because the first octet falls in between this classification, the class C classification. Needless to say, this one also falls where, in class what? Class A. Yes, you guessed right. Class A. This is a 175. Where does 175 fall into? It falls in, yeah, class B. Class B IP addresses. Okay. Now, we are looking at the first octet. You can guess which class the IP address falls into. What is the essence of all these guys? Why do you put them in classes? You know, in class A, IP address, we have the first 2 octets. No, the first octet is used for what? Network addressing. Remember this when we're talking about subnet mask network address, and here the remaining are what, used for what? Host addressing. That means the surname, the vicinity, the area name, uh, is what, is categorized or symbolized by the first octet. That means the first octet is used for the network address. So in this case, I can have something like 10.0.0.0. This is a network address. So we'll talk about types of IP address very soon. And that's the next one we're going to talk about. Okay, this is the network address. What I keep on doing the same thing. This is the network address of a particular IP address range. All right, but in this case, this is a class A um, 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 IP address, in the sense that it has its first octet within this range. Now, if you take a look at this place, when I was talking about subnet mask, I'm still going to sit down and talk about subnet mask in a later topic, where I blow it open, where we talk about subnetting. But here you can see that when in the subnet mask, your subnet mask helps you to know which part is used for network address and which part is used for host addressing. So invariably, what I'm saying is that in class A, the default subnet mask is what? 255.0.0.0. Remember, when you see a 255, it means network. When you see a 0, what means host name. Alright? Do you get me? If you're going too fast, you can call my attention. Oh no, sorry, you can't call my attention, but you can rewind. All right, rewind, listen to it again, see the first part, IP addresses, part one, and come back and see this place. You understand better. So the same thing goes for class B. In class B IP addressing, we have the first 2 octets used for what, network address, and the last 2 octets used for host addressing. In class A, invariably you know that we can have more hosts per network, per individual network, in the sense that we can have 255 times 255 times 255, which is, oh, I want to quickly do mathematics. 255 raised to power 3. Where's raised to power? I can't find raised to power, so I just write times 255 times 255. So invariably, per network, you can have 16 million hosts per network. What do I mean? Per individual network, let's say this is a switch. Hmm? We can, if we want to use um, class A IP addressing, we can have a minimum of 16 million and a fraction in this single network. That means we can have more addresses per more host addresses per network. All right. So you probably don't understand much, but just take it like that. If we are taking CCNA class, I will have expatiated more. In fact, by the time I get here, you will have understood more what I was talking about. But in this case, we use more hosts per network, and the default gateway for class A IP address is what 255.255.0.0.0. For class B, you can guess, all right. Where you see a network, when you see 255 means network, right? When you say 255, it means which part of the IP address is used for networking. And of course, when you see an H is a 0. So this is the default gateway for the default subnet mask for for a class B. Am I eating this afternoon? Why am I confusing my terminologies? Okay, don't mind me. What I wanted to say was for class B, the default subnet mask for class B is 255.255.0.0. All right. Now, I just had a cup of G2S so far, and it was lovely. I think that's what is capturing my brain. Okay, excuse me. For class C, IP addresses, we have, of course, we have the first three octets used for network addressing, and the last octet used for host addressing. That means we have more networks and hosts, which looks a little bit more workable here, because in this case the maximum number of hosts per network we can have is actually hmm, I'm tempted to say 255. Yes, let's say 255. This is primary one. Let's say 255. When we get to primary two, I'll tell you that there is a minus two somewhere. All right, and what those two is, I'll tell you very soon. So, uh, so the default, of course, you can guess the default subnet mask for class C IP addresses is the first three octets used for networking 255.255.255.0. Right? Okay, so that is class A, class B, class C IP addressing. That is what we have under the first subnet mask, which part of the IP address is used for network addressing, and which part of the IP address is used for host addressing. All right. So that said, we go to class D IP addresses. Class D IP addresses is is reserved for multicasting. Multicasting is one to many kind of communication. How do I mean? Let me start from the basics. You have unicast. That is a one to one. If Boo is talking to B, Boo is talking to B, and B is talking to Boo. Alright? Now, takes us to the next kind of communication, multicast. If I enter a classroom and say, everybody in a blue shirt, stand up. Peradventure, I'm the teacher and I told them not to wear blue shirt in my class when I'm training or when I'm teaching, and I'm hungry and I enter the class. I saw people wearing blue shirts, I saw some people in red, I saw some people in green, I saw some people in white, and I announced, everybody wearing a blue shirt, stand up and come towards me. Now I have cut out a range of people and I'm speaking to them directly. Everybody that is wearing a red shirt will not listen to me because I'm only speaking to people who have blue shirts. So what I'll call this kind of communication is one to many. Then of course, we have broadcasts, one to all. All right, broadcast. I'm speaking to everybody. Like I went to Maryland Common Private School, and we used to have a teacher. I can't remember his name. He just walks into his class, into the class, and say, "Everybody sleep." Once you hear everybody sleep, know you are in trouble in that class. He's going to beat everybody in that class. He is going to beat everybody in that class. All right. So once you hear everybody sleep, everybody puts their head on the table. So everybody sleep. Ha ha ha. I got you. I thought you were gonna sleep. Okay, so that is one to hold broadcast. So excuse me. Why would you want to multicast? That is beyond the scope of this class for today. For now, it's beyond the scope of this class. But the class D IP addressing is reserved for multicasting, and class E IP addressing is reserved for experiments. Is experimental, used for experiments. Which experiment? Oh well, I can help you look for the email of Apipa. Is it Apipa or internet? Internet assign Ayana. Yes, Ayana. Yes, I wish to ask them myself. Why did you reserve chunks of IP address for experiments? Which experiments are you performing? I don't know, right? But it's reserved for what? Experimentation, right? These are the classes of IP addresses that we have in IPv4. Hmm. I remember telling us uh, that in IPv4 we have just so much IP addresses, and if every devices on the planet Earth that is supposed to have an IP address has an IP address, we will have run out of IPv4 IP addresses 10 times over. I remember saying that. Now, what has been keeping us still in using IP addressing um, is what I'm going to talk. Is IP addressing version 4 is what I'm going to talk about next. The types of IP addresses, where we have private and public IP addresses. All right. So that is the next thing we're going to be talking about. Okay. Before I talk about it, let me just mention one or two things. Yeah, I'm in a mood right now. One of the things is private IP addresses, and what we call uh, yes, 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 network address translation. NAT. In my CCNA class, I'm going to expose this fully. Network address translation. In fact, that is a blessing and a curse. This is this guy, these two guys are solely responsible for us not moving to IPv6. Solely responsible for us not moving to IPv6. In fact, if IPv6 has been around for quite a while now, but it doesn't just seem to catch on because we are able to find a way of getting ourselves round and round and round IPv4, and it's not just exhausting. It's not running out, but it will run out one day, and we will need to go to IPv6. So let's move on to the next topic. If you want more on this, you can call me, leave a comment, or sign up for my CCNA class. Let me clean this up. All cleaned up. Let's move forward. Types of IP addresses. Now, I told you one of the guys responsible for us not running out of IP addresses is we having private IP addresses. Private IP addresses. What are these? The powers that be the powers that be decided to cut out um, um, chunks of IP addresses from from each class. And before I even move forward, there was something missing. I had hoped somebody was going to call my attention to. In type of IP address, I'll tell you. Now, the powers that be decided to cut out chunks of IP addresses in in IP address uh, classes in each class and says, okay, these IP addresses are not allowed on the internet. Now, when we were learning, they tell us that it is not routable. No, they are actually routable, but they are being what blocked by ISPs. How do I mean? Let's take for example, this is the internet, right? Your ISP is here. This is your ISP. Connects to your router, which connects to your switch. Somehow connects to your switch. If this looks like a switch at all, okay, let me do a proper switch. Okay, connects to your switch. This guy connects to your router, and you have devices connected to your switch one way or the other, either using wireless or whatever you want to use. Now, and you have another office somewhere. This is my own office, and connected to my ISP somewhere here, which is connected to my own switch too, and I have devices connected to my whatever to my switch. Now, in this network, I can decide to say, okay, I want to give myself um, an IP address in this range. I say, naturally, without private IP addresses, and if everybody is on the internet, no restriction, all you just do is get on the internet. If I have a particular IP address, 192.168. Say 5.1, only me in the whole world can use this IP address as it is. Only me can use this home address as it is on the internet. Hmm? But with the advent of private IP address, let me type out all the private IP addresses. Now, this are the private IP addresses range. Any address that falls with this range, of course, from here, from our last slide, this is a class A IP address range, this is a class B IP address range, and this is a class C IP address range. So what was I saying? I was saying if there were no restrictions and there was no private, no public IP addresses, this guy and is assigned to my system in the whole wide world on the internet. Only me can use this address. All right, that's how it is. But with private IP addresses, it's so configured that inside this my network here, I can use a private address range. Why? Because if this guy is trying to communicate on the internet and it's going out with his address 192.168.5.1 and it gets to the ISP before it hits the internet, the ISP is so configured to deny and block every packet from this IP ranges from 10.0.0 to 10.0.25, 10.25.25.25, 172.16.00 to 172.31.255.255, and same too for 192.168.00 to 192.168.255.255. Once it gets here to the ISP puts what we call an ACL and checks source IP address 192.168.5.1. Up, out, out. You are not allowed to pass. I'm going to drop this packet. So it doesn't get to the internet. Oh, are you getting the whole picture? Therefore, admin B here, network admin B here, can assign this guy 192.168.5.1 Are you seeing it? You can assign him that same IP address. Why? Because if he's trying to access the internet with that IP address, once it gets to his ISP, the ISP is so configured to deny these network address ranges and says, okay, you are from 5.1, I'm going to drop that packet, it's not going to get on the internet. Therefore, this network A here, will not know that network B is using the same IP address here. Are you getting me? So how then does this guy get on the internet to be able to access Yahoo servers, Google servers, Gmail, and whatever you want to access? That is where network address translation comes into place. We'll talk about that in CCNA class. Basically, what it does is once it's hitting the router will map that address such that the router is going to have a public IP address configured on it. A public IP address is an IP address that is not inside this range, either for class A, class B, or class C. So it will have one configured on the internet facing interface. So as the data is reaching here, is automatically translated as if it's coming from this IP address, the public IP address. Let's say it's 3.3.3.3. I'm just choosing an IP address. So once it's going out this interface, it will look as if it's coming from a source IP address of 3.3.3.3. So that when it gets to the ISP is, oh, great, it's coming from 3.3.3. I'm going to allow it pass. So go to wherever you want to go to. Are you getting me? And when that wherever he wants to get to is also replying, it replies to 3.3.3 through this ISP guy. It gets here because he is the one that did the mapping from internal to external. He knows where to route it back to 5.1. Basically, this is private and public IP addressing in all of its glory. In all of its glory. Yeah. I'm trying to say, did I leave anything out? I didn't. I didn't. Okay. Now let me paint a funny scenario. What if I have another network here connected to a switch which has devices on that switch, and each device, let's say this device, is configured to look for DHCP. How do you tell it to look for DHCP? Remember when we were here, when I told you go to change adapter settings, and you tell it to go look for obtain IP address automatically, obtain DNS server address automatically. Once you tell it this, you're telling it to get its IP address from a DHCP server. So it goes looking for a DHCP. Now, peradventure it goes looking for a DHCP, and there is no DHCP on the network to address it, to address its request. What happened? This system is going to automatically give itself an IP address. Yes, it will automatically give itself an IP address, and that IP address is reserved. It's reserved, and it starts with 169.254.0.0. This is the network address. Now, the powers that be determine the thought of this kind of scenario. What if the system can't find a DHCP server? What does it then do? Does it keep on trying to look for one, or does it assign itself an IP address? Yes, they decided in this network or in any network whatsoever, it should auto assign itself a an IP address in this range 168.254.0.0 to 168 to 168 dot, oh sorry, 169 dot 254 dot 255 dot 255. It's just going to randomly pick any IP address in that range. That's how many IP addresses is that? 255 times 255. So it's going to pick any IP address in that range to assign to itself. Alright, that is another type of IP address. We've talked about one, private. We've talked about two, public. Of course, public is anything that is not inside this range that can be routed on the internet, that is permitted on the internet. That's the politically more correct English to use. Permitted on the internet. Alright, okay, so that said, we'll move on to, we've talked about the auto assigning. Auto assign. Let's confirm if my system actually did auto assign itself. I I I I I did that for the Ethernet network. I'm using the Wi-Fi network. So let's do an IP config and let's see IP config. Blah blah blah. Yeah, blah blah blah. I have my wireless Ethernet. Nothing is connected to it. If peradventure I connect the cable to it right now, it's going to try to connect to a DHCP server, and when it does cannot find, it says media disconnected. If I connected the cable to it now and I plug it in on the network, it's going to try to find a DHCP server because I told it to look for a DHCP server and obtain IP address from a DHCP server. So it's going to try to look for a DHCP server, and then after that, it's going to try. If you can't find one, it's going to try to auto. In fact, not try. It's going to actually auto configure itself in this range. All right. Okay. Two more things, and we'll be done with this IP addressing. Let me quickly clean out this and talk about the last two concepts for this topic, and I'll call it a day. We'll draw the curtains on this. Um, One of them is, if you were observant enough, you'll see that I left out an IP address, or I missed out purposely. When I wrote my class A IP address, and my writing is looking like now. I said anything that has 1 to 126, and my class B anything that has 128 to 191. 191. Something is missing here between 126 and 128. Yeah, I got you. 127. What happens to addresses that start with 127? 127.0.0.1, 127.100.1.1.0.1. What happened to every addresses that um, start with 127? So, what's it? This is what we call a loop back address. Loop back address. Let me write the full address out. 127.0.0.0 to the range of 127.255.255.255. Wow. You see, when the people that created the IP addressing scheme did, they left out, this is about 255 times 255 times 255. This is about 16 million, what's a fraction, addresses. Yes, in this range, within this range, this is about 16 million addresses. Guess what they left you for? You cannot imagine. Testing. Testing. What is it testing? It's testing itself. More like saying me, mine. My name is Olufemi Bakari, but when I want to talk about a pen that belongs to me, I'll say this is my pen. So it's kind of testing itself. Do I have um um um, what was it called? Uh, a network adapter. Is my network adapter working well? Do I have TCP/IP? The TCP suite enabled. All those. That's just what it's testing. If you go to any network device on your network right now, and you go to your CMD, you go to your command prompt, and you test. The funny thing, for of the 16 million addresses that they left for just testing, people end up only using one of them. That is 127.0.0.1. I could use any one of the 16 million addresses inside this range right now to test for my connectivity. But most of we settle for one, and we clicks OK. You are meant to get a reply. Yes, that is testing itself. It's testing more like a look back. It's testing. Am I okay? Do I have connectivity to myself? Can I? Is my TCP/IP suite working fine? That is basically just what it's testing. All right. If peradventure you do this and you don't get a reply, or you're getting something else other than what you're seeing on the screen, that means there's a problem. That means there's a fundamental problem with either the TCP/IP stack of protocol suites or the network adapter. All right, that is this another kind of type of IP address that we have. That is the loopback IP addressing. Now, the last one we're going to be talking about is the special IP addressing. Now, when I was telling you the number of valid IP address inside a particular range, when I was talking about Class C IP addressing, and I told you that we could have 256 IP address. Yes, and I said it was primary one, and there's a -2 somewhere. Now I'm moving you to primary two right now. I'm going to tell you where the -2 is. The special IP addresses that we don't assign to any host in the network is the very first IP in the IP address in the range, and the last IP address in the range. Sorry, my hand is bent. Okay, so the first IP address in the range is what we call the network address. The last IP address in the range is what we call what? Huh? I'm listening. The broadcast address. What do I mean? Let's take for example, um, 192.168.1.0 with a subnet mask of 255.255.255.0, or if I don't want to write it that way, I have a shorter method of writing that 255.255.255.0 slash 24. What do I mean by slash 24? Remember, each 255 is what? 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. All 8 bits turned on, right? Dot. All 8 bits turned on plus all 8 bits turned on. Add 8 plus 8 plus 8. That will give me what? 24. Okay? When we're doing subnetting, we'll talk more about this. Is what we call the CIDR value, classless interdomain routing value. Okay, so this is a shorter form of writing my subnet mask slash 24. Slash 24 means 255.255.255.0 slash 16. Of course, for this is a class C IP address, right? For class B is what? Slash 16, which is 255.255.0.0. Of course, you can get slash the dash the class A. Class A's own is slash what? 8, because we have just 255.0.0, and that 255 is only 8 bits turned on. Alright, so that is the CIDR value. Now let me move on. Now, in this IP address, in this network range, in fact, if I write this guy out right now, let me clean out the dash 24 slash 24. I keep on calling it dash. This slash 24. Let me clean it out. Let me write this address in full. The last address in this range is going to be 192.168.255.255. Sorry, dot 1.255. This should be one. Dot 1.255. Now slash 24. I can now put my slash 24 here. Now this is the first address in this network range, and this is the last address in this network range. We don't assign this first address to the system. Why? Because we call it what? The network address. Pretty much like the surname. Pretty much like the surname. Everybody in my family bears Bakari because that is the network address. So, yes, that's the network address of everybody. I'm talking like a nerd right now. That's the network address of everybody. The Bakaris. So in this terminology, we call it the 192.166.1.0 slash 24. Don't forget that part. Hmm? I'm going to put it somewhere slash 24. It's very significant. Do you get it? That is like the network address. But this is like uh, the broadcast address. Broadcast address. If I want to send message to everybody inside this range, 1.1, 1.2, 1.3, 1.4, 1.2, 1.254, then I want to send it to everybody instead of having to send it to 1.1 they separate, 1.2 separate. I just announce it. And how do I announce it? This is our megaphone. Yes, this is our megaphone. I just send it to this guy. This guy amplifies it to everybody that is a member of this network. Simple. That these are the two special IP addresses, the first and the last IP addresses. So when I say when I'm doing subnetting, I'll give you a formula: 2 raised to power n minus 2. That minus 2 is this network address and broadcast address. This is this is the formula for number of valid hosts in a network, where n is something. I won't tell you now. Yeah, n is something. I won't tell you now. All right. So in this nugget, we've talked about types of IP addresses, classes of IP addresses, methods of assigning IP addresses to clients or to hosts in our network. And generally, we've talked about IP addressing, moving around in the network, how you use your IP address, your subnet mask, and combine it with a default gateway to reach remote hosts. And we talked about binary, where in our first one of the first part of this whole series, when we talked about binary, then we talked about IP address part one, then this IP address part two that we're rounding up now. Basically, I think I've covered IP address at least in layman terms. All right. So, rounding up, I still feel like talking about these special IP addresses, but don't worry, you grab you. I believe you got it. Special IP addresses, you don't assign a network address and a broadcast address to host on your network. Wow. I hope this has been very, very informative for us, for you. And thank you for taking your time out to view this. Thank you. And don't forget to leave your comments. Bye.